So, in this video lecture, you are going to understand Taylor series and Laurent series. So, starting with Taylor series defined in a circle with center A. So, if fz is analytic inside a circle C, whose center is A, and z is a point within the circle, then f of z can be expanded as fa plus z minus a into f dash a plus z minus a whole square 1 factorial to f double dash a up to z minus a whole to the power n nth derivative of fz at z is equal to a and so on up to infinity. So this is your Taylor series. You do remember this. Next is Laurent series, and as you can see, it is defined in a ring-shaped region. So if fz is analytic in a ring-shaped region bounded by two concentric circles C1 and C2 of radii R1 and R2, where R2 is greater than R1. So the circle C1 is inside the circle C2, and if fz is analytic in this ring-shaped region and C is any closed curve within this ring shaped region and z is a point in this ring, then f of z can be expanded using Laurent series, and Laurent series says that f of z is equal to a0 plus a1 z minus a plus a2 z minus a whole square and so on up to infinity plus a subscript minus 1 into z minus a inverse plus a subscript minus 2 into z minus a to the power minus 2 and so on up to infinity, where the coefficients can be calculated using this formula. An is equal to 1 upon 2 pi I into integration of fz upon z minus a whole to the power n plus 1 with respect to z along the curve C, where the curve C is lying in this ring shaped region. So this is the formula for Laurent series. Now you note that to obtain Laurent or Taylor series, we don't use to find these coefficients using this formula. So what to do is we just simply expand fz using binomial theorem. So binomial theorem says that if mod z is less than 1, then 1 minus z inverse can be expanded using the formula 1 minus z inverse is equal to 1 plus z square plus z cube and so on up to infinity. And 1 plus z inverse is equal to 1 minus z plus z square minus z cube and so on up to infinity. So let's solve some examples. So this is your first example. In this example, we have to expand f of z is equal to 1 upon z minus 1 into z minus 2 in various regions. So first region is mod z is less than 1, second is mod z is greater than 1 but less than 2, third is mod z is greater than 2, and fourth is mod z minus 1 is greater than 0 but less than 1. So since f of z is 1 upon z minus 1 into z minus 2, then by using partial fraction, it can be written as 1 upon z minus 2 minus 1 upon z minus 1, and you take it as equation number 1. Now, our first region. So for the region mod z is less than 1. Since our f of z is equal to 1 upon z minus 2 minus 1 upon z minus 1, and we have to use binomial theorem, and the condition is that mod z should be less than 1 to expand 1 minus z inverse or 1 plus z inverse. So since mod z is less than 1, therefore by taking minus 1 common from here, it can be written like 1 upon minus 1 into 1 minus z, and the mod of z is less than 1, therefore it can be expanded using binomial theorem. And what about this? Since mod z is less than 1, so dividing both sides by 2, mod z by 2 is less than 1. Therefore taking minus 2 common from here, it will be 1 upon minus 2 into 1 minus z by 2. Now since mod of z by 2 is less than 1, therefore we can apply binomial theorem over here, and it can be expanded using binomial theorem. So now we can use binomial theorem in both the terms. So using binomial theorem, the expansion will be minus 1 by 2 into 1 plus z by 2 plus z square by 4 and so on. And here it is 1 plus z square and so on up to infinity. So as we can see, there is no negative powers of z. There is no negative powers. Therefore the series is a Taylor series. Since Laurent series is having some negative powers also. Next region, for the region mod z greater than 1 and less than 2. Since our f of z is 1 upon z minus 2 minus 1 upon z minus 1. So consider this term. Since mod z is greater than 1, therefore if I take z as common, this will be 1 minus 1 upon z. Now since mod z is greater than 1, so divide both the sides in this portion, it will be 1 upon z mod is less than 1. So since mod of 1 by z is less than 1, therefore now this bracket can be expanded using binomial theorem. And in the first term, since see this portion, mod z is less than 2. Therefore, by dividing both sides by 2, we can get mod of z by 2 is less than 1. Therefore, if we take minus 2 as common from the denominator, it will be 1 minus z by 2. And we have shown that mod of z by 2 is less than 1. Therefore, this bracket can be expanded using binomial theorem. Therefore, it can be written like minus 1 by 2 into 1 minus z by 2 inverse into minus 1 by z into 1 minus 1 by z inverse. Now, since mod z by 2 is less than 1 and mod 1 by z is also less than 1, therefore, we can use binomial theorem, and it can be expanded using binomial theorem. So it is now minus 1 by 2 into 1 plus z by 2 plus z square by 4 and so on up to infinity. And here the second term will be minus 1 by z into 1 plus 1 by z plus 1 by z square and so on up to infinity. So since it contains negative powers of z, therefore this series is a Laurent series. Now move forward to third region. For mod z greater than 2, since f of z is 1 upon z minus 2 minus 1 upon z minus 1. Since mod z is greater than 2, therefore divide both the sides by mod z, it will be mod 2 by z is less than 1. Since mod 2 by z is less than 1, therefore mod 1 by z, which is less than 2 by z, will be also less than 1. So we have shown that mod 2 by z and mod 1 by z both are less than 1. So by taking z common in the first term, it will be 1 upon z into 1 minus 2 by z. Now this mod 2 by z, we have shown that it is less than 1. Therefore this bracket can be expanded using binomial theorem. And from the second term, if we take z as common from the denominator will be z into 1 minus 1 by z, and we have shown that mod of 1 by z is less than 1. Therefore this bracket can be expanded using binomial theorem. So applying binomial theorem, the series is expanded like this. It is 1 by z into 1 plus 2 by z plus 4 by z square plus 8 by z cube and so on up to infinity minus 1 by z into 1 plus 1 by z plus 1 by z square and so on up to infinity. Since it has so many negative powers of z, therefore the series is a Laurent series. Now let's see our next region, and the next region is mod z minus 1 is greater than 0 but less than 1, and our f of z is 1 upon z minus 2 minus 1 upon z minus 1. So let's take z minus 1 is equal to t. Let z minus 1 is equal to t. So this can be written as 1 upon t, and this can be z minus 1 minus 1 means 1 upon t minus 1. So the fz is transformed to f of t, and f of t will be 1 upon t minus 1 minus 1 upon t if we put z minus 1 is equal to t. Now since the region is mod z is less than 1, so in place of z minus 1 we can put t. So the region is mod t is less than 1. Since mod t is less than 1, since from the first term we can take minus 1 as common, therefore the denominator will be minus 1 into 1 minus t, and we have shown that the mod t is less than 1. Therefore this bracket can be expanded using binomial theorem. So this can be written like minus 1 into 1 minus t inverse, and by using and this is the single term, so no need to expand it. So this can be expanded using binomial theorem. So it will be 1 plus t square plus t cube up to infinity. And in place of t now we have to put z minus 1. So the expansion of fourth region is minus 1 plus z minus 1 plus z minus 1 whole square and so on up to infinity minus 1 upon z minus 1. Since it has a negative power of z or z minus 1. Therefore, this series is a Laurent series. Now, we have our next question. In this question, we have to find out Laurent series of fz is equal to 7z minus 2 upon z plus 1 into z minus 2 in the region that the value of z plus 1 is greater than 1 but it is less than 3. Since it is clear that z is a positive quantity. Now, since f of z is 7z minus 2 upon z plus 1 into z minus 2. So, by taking z plus 1 is equal to t, we can put z is equal to t minus 1. So f of z can be changed into f of t by putting z is equal to t minus 1. So it will be 7 t minus 1 minus 2 upon t minus 1 plus 1, that will be t into t minus 1 into t minus 1 minus 2, that is t minus 3. So f of t will be now 7t minus 9 upon t into t minus 1 into t minus 3. Now using partial fraction over here, if we use partial fraction in this part, the f of t can be written as minus 3 by t plus 1 upon t minus 1 plus 2 upon t minus 3. Now since the region was that mod that z plus 1 is greater than 1 but less than 3, so in place of z plus 1 we can place t. So t will be greater than 1 but less than 3, and since t is a positive quantity, therefore we can write that mod t is greater than 1. Therefore we can write that mod 1 upon t is less than 1. If we divide both the sides from here, if we divide it by mod t, since mod t is greater than 1, therefore mod 1 by t is less than 1. So it is a single term, so no need to expand it here. If we take t as common, it will be 1 minus 1 by t, and we have shown that mod 1 upon t is less than 1. Therefore we can apply binomial theorem here, and from here, since t is less than 3, that means mod t is also less than 3. Therefore divide both the sides by 3. From this part, if we divide both the sides by 3, mod t by 3 is less than 1. Therefore, from this term, from this denominator, if we take minus 3 as common, it will be minus 3 into 1 minus t by 3, and we have shown that mod t by 3 is less than 1. Therefore, this bracket can be expanded using binomial theorem. So, by applying binomial theorem in the second and third term, they can be expanded. So finally the expansion of f of t is equal to minus 3 by t plus 1 by t into 1 plus 1 by t plus 1 by t square and so on up to infinity minus 2 by 3, 1 plus t by 3 plus t square by 9 and so on up to infinity. Now in place of t we put z plus 1. So f of z will be minus 3 upon z plus 1 plus 1 upon z plus 1 plus 1 upon z plus 1 whole square and so on up to infinity minus 2 by 3 into 1 plus z plus 1 by 3 plus z plus 1 square by 9 and so on up to infinity. So since this series has negative powers of z plus 1, therefore the series is a Laurent series. In next video lecture, we will see some more examples of Laurent's and Taylor series. Thank you.